Okay, so today I will do the things I didn't manage to do on the last lecture here. So I'm going to go through some of the tools that you can need if you are going to work with Fortran development. So it's not so much about Fortran, the language itself, but how you compile and build Fortran programs. Yeah, so maintaining Fortran code. So when your program grows, when you have more source code files, also you get requirements for building on multiple platforms, such as Windows, Linux, and Mac. You need to kind of think about how you build it and how you can provide a way for people to build your code. And of course, you can create shell scripts that builds the software. Problem with that is that perhaps you don't have the shell script environment on all platforms. For example, Windows doesn't have a bash shell as default. Also, it's really hard to handle dependencies. So for example, if you have 20 source code files and there are some of these files needs to build before the other ones, it's really hard to do that automatically. And also, every time you change a file, if you run your script, it will rebuild every file. So, and that is could take some time to do. And there are some tools to solve these problems, and I will go through them in a reverse order. So I will show you the more complicated first, and then something that makes it much easier later on. So the tools are make and CMake. So we'll start with make. And make is a really old tool, has been around since the 70s, that is really good at handling dependencies on different things and building, doing things depending on certain criteria. So you set up a set of rules for how you want to build your software, and it will automatically handle all the dependency for you. So if you have you change the source code file, it will detect, oh, this file has changed, I need to rebuild my binaries. And it only rebuilds the things that actually are required to be rebuilt. And it's available on all platforms. An interesting side note is that Windows is actually built using GNU Make. So it's a tool that is used not only on Linux and Unix, but it can be used in Windows as well. It can be kind of non-intuitive in the beginning, which I will show you here. So I hope I will kind of describe how you can use it. So the syntax is a bit special. So you specify a target, and that is kind of the name of the rule, so what you want to achieve. And you have a colon, and then afterwards you can list a set of dependencies. So to build this target, you first have to build the dependencies. And then you have the next line here, you have a tab character. And after the tab character, you provide a command to achieve that target. And it has to be a tab character. So for example, if you start with a very simple example, I want to compress a file. So for example, GC is a GNU zip, and I want to create my file gzip from my text file here. So the dependency here to create my target, my file gc, is myfile.txt. In the next line here, I need to provide a rule how to come from myfile.txt to a zipped file. And you don't have the exact details here. Is I cat my file, I pipe it through gzip, which outputs this file here. And I can show you how this looks in live here. So I have in my folder here, I have two files. My file.txt is my text file, and my make file is the make file. And the thing is that if you name it make file with an uppercase M, and you type make the command, it will automatically use this file. So if we look at what the content of that is, here I have my rule here. There is a national rule here, a specific target for cleaning up as well, but we can ignore that for the moment. Then I type make, and you can see here that it created my gzip file here. So if I look here, I have my file.gc here now as well. But if I type make again, it says, okay, it's up to date. I don't have to do anything. Because my file gc here, I haven't made any changes to this file here, so it doesn't have to do anything with that. What I can do then is I can do touch, which is updates the date of the file here. So if I touch my file.txt, that's the same thing as going into and editing that file. If I do make again here, you can see it builds again. So it detects if something has changed and looks if, do I really have to do it? No, and then I don't do it, or it has been changed and then it will do it again. So it's a nice way of handling dependencies in different ways. So the rule, the target, the name of the thing that you want to achieve, any dependency that is required for that rule to be fulfilled, and then you also provide a recipe for going from to implementing the rule. So I already did that, so I can skip that. So you can see here that this can be kind of a good tool to actually build source code as well. So when you build executable files, you need to compile a set of source code files into object files, and you have to link them together to form an executable. If you use the Fortran command directly, you can do that in one single step. But when you want to do larger project, it's very useful to build starting with the object files and then linking together, because if you change a single source code file, you don't have to recreate all the object files again. So that's the idea, that you go from source code to object files, and then you also have a rule for linking together at the end. So object files have a natural dependency on a source code file. So you go from source code to object file. And an executable depends on the object files. So an executable is you link together all the object files into an executable. So this is a case for make. So what we can do then is, the final goal here is I want to create an executable myprog. That is the high level target. And it depends on a myprog.o. And you need to link that together in the first step here as well. But you see here, it depends on myprog.o. So let's create a rule for myprog.o. And that, of course, depends on myprog.f90. And then there is a rule for building that object file here as well. So we have this one here and this one here. So let's see if I can find that one here as well. So you can see here I have a single source code file in Fortran. You can look at that. Looks like this. And the make file is like this. So if I do make now, so the first thing it does is because my executable depends on myprog.o. So the first rule it has to do is to create object file. So you can see here, it recognizes here that I can't complete this rule here until this rule has been completed. So then the first thing it does is it compiles myprog.f90. That will generate myprog.o. And then the second step, it links them together here. Fortran myprog.o, output an executable from that. And if you look at my list here now, you can see here, I have myprog here, which is executable. I have my O file here, and then I can run my program here as well, like that. So a bit more extensive example here. I have two source code files. So then I put one rule for each of them. So I have my module here. I have myprog.o. And then you can see myprog here depends on both of these object files. and then you have a rule for linking them together. So let's go into just going to remove the so I have two files here, and I have my make file here, like this. And if I build it here, it should build them first my prog and then my module, and then link them together. So what happens now if I change one single file? So let's change my module file here. Touch my module. And if I run make again, you can see here, it only recompiles my module because it knows that my prog is, that object file hasn't, the source code hasn't changed, so I don't need to rebuild that one again. One thing to think about though, when we come to Fortran 90. So in Fortran 77, you can build in any order a source code file. But when it comes to Fortran 90, especially modules, you need to actually compile them in a certain order. And because when you build a module file, it creates a special export statement or a .mod file that needs to be available for another program to be able to, when you compile that source code file, it needs to find that mod file. So you need to do that in a certain order. So you have to start with the module that is the highest module dependent that you have, and going down. So if you have a module that doesn't have any dependence, you start with that one. And then if other modules depend on that module has been compiled first. But we can do that again. Let's see here if we can. So here I have a, so the right one here. Yeah. So in this case here, I have I have my prog here, and I have my files here that depend on. I have a module main here .o, and you can see here that you have a rule here that it depends, of course, on the source code file. But if you look at the main cat module main. You can see here it has this use truss. So we need to make sure that the truss module is built before the main one. And what we can do then is actually, we can just add dependencies here. So we can say to make here that actually this has to be built before. So I can just say module truss O is a dependency here for module main. That will force module truss to be built first. And then it should work. So if we let's see here, you can see it starts building module truss here because that is a dependency of module main, and then you can link it together again. And you can see here, if you look at this is the thing that is created when you build a module. It creates a file that contains the interfaces that is required for the compilation. And that has to be available when you compile module main, because it says use truss. It looks for this file, and if it's not there, it doesn't work. So if we do, we can just try it here to see what happens if we don't have this one here. You can see here that cannot open module file trust mod for reading at, because so it misses this file. So that forces them to build in the correct order.
Is it important for me to know how make actually does is how it reads the file, or should I just make sure if I write things in the right order? Because I guess it will look at the dependencies of the first thing it encounters and say, okay, I don't have these. Look for a rule later on.
So you don't have to order in a special order here.
Okay.
It's just that it has to kind of find the rules in the make files to do it. So you can already see we repeat ourselves a lot in the make file here. So what we can do, just like any programming language, make also can handle variables. So by using variables, we don't have to copy and paste a lot of things. We can put something in a variable and reuse that in the rules. And it makes the make files easier to use and also easier to read. The variable name, you give it variable name equals the value, and then you refer to it using a dollar parenthesis. So here we have, for example, I want to be able to configure flags in a single place. We're going to say that FC, I can set the Fortran compiler. I can give the flags, and I can also name the executable. And then I can change my makefile to have here, instead of specify the executable here, I can put the executable as a variable. I put the FC here as the compiler, and I add the flags here. And I don't have to repeat myself and copy the rules to every the settings to every rule I have. So I can change everything in a single spot here. And you can see this is also a good idea to have. So have a rule for cleaning. And that doesn't depend on anything. But here you have your recipe for cleaning up your build. So for example, Fortran could be removing all the object files, removing all the mod files, and removing the binary. That will clean the build tree. Then there are some other things as well that can make things easier for us, so that you don't have to repeat anything. It automates things even more. So here you have $at, that is the target of the current rule executed, dollar raised by, name of all the prerequisites, name of the first prerequisite. So what does that mean? So here we have a rule for building an executable. So you have the dependencies here. And then you can see here, okay, this is the compiler. And then I want to have the name of this was the name of all the prerequisites. And then output the current rule here, the current name here in this one here. And then you can have a generic rule that doesn't have any connections to actual names here. So this will point back here to this name here, and this will point to these dependencies here, which will go into the compilation here as well. So here you will give compile here myprog mymodule.o output, and then it should be named like the rule name here. So it's very short and compact. And you can also have, so this is the back to myprog.o, and this will point to the dependency here, the first one here. Then there are some other rules as well that can make it even easier to maintain a large number of source code files. So instead of specifying every file you want to compile, you can give recipes for how you achieve a certain goal. For example, going from a .o file to a .f90 to a .o file, you can define generic rules for that. And here, for example, you can have a rule that's called .f90.o. That means a rule how to convert an F90 file to an object file. So then you give this kind of simplified rule here, and then you can add additional suffixes here using the dot suffixes rule here. Now I think most modern make, you don't have to do it. It knows about these here. So this is just if you want to add some additional ones that are supposed to be used by this one here.
How does it read the first dependency name here?
Sorry?
That it. How is that interpreted?
I think it will pick that up if you have it will automatically provided using this rule. So you don't have to think about what it picks up, because this will figure out. So actually, if it finds a F90 file, it will be kind of here.
It will automatically understand that sort of file name .f90
Yeah.
produce file name .o.
Yeah, so it will know how to go.
In the variable.
Yeah. That's why it's hard to read makefiles. So it's a lot of strange macros and stuff like that. So, and then there are even more things you can do. You can do wildcard expansion, and I better show an example of that here. So, for example, I can create lists of files, and then important to note here, you don't use equal sign here. You do colon equal to, and then $wildcard.star90. Then you get a set of files. And then you can do stuff like that. For example, you can create a set of object files by doing path substitution from F90 to .o and use this list here. Then you have a set of object files for your project. So it looks in your current directory and finds all the F90 files, and then you can create objects from that. So then you can do stuff like this. Executable colon objects, and that is a single rule for everything. And then you also have pattern rules, and this is the recommended way in GNU Make to have this kind of rules. So it looks something like this. You have this here, %o.%f90, and that is the kind of the preferred way of doing it today. Still, you need to put. It doesn't know about F90 and module under this .mod file. So even if you have all this automation now, you still need to tell it that this module depends on that module. That is something you need to do manually anyway. But otherwise, we have two rules here to build our executable. We have our variables here where we can specify what goes into our project, and we have a single rule to kind of create the object files, and we have a cleaner section here as well. But now that I showed a complicated way, I will try to. Not everybody agrees with me that this is the least not so complicated way, but there is another make file system or build system that is called CMake. And CMake is a build file generator. So it can generate not only build files for make files, it can generate project files for development environment as well. So if you're on a Mac, you can generate project files for Xcode. On a Windows machine, you can do it for Visual Studio. And there is no specific things in those, so you can provide a CMake files, and the user of this can choose what kind of environment they want to use. So it's a cross-platform build system, and it generates build files, as I said. And the thing that is interesting, it is not a rule-based language; it's actually a programming language. So you can create your build. You describe your build system using subroutines and procedures. So it looks similar like this. So you have this is you have to specify this in the beginning here to tell the user of this CMake file what version it has been produced with. So it makes sure that the syntax will be the same. If you have a newer version of CMake, it knows what kind of syntax to parse this file with. So it's kind of a way of making it, ensuring that your make file is compatible even if the language has changed later on. But the most important thing is that you do project simple here. And that is not the executable. This is just the name of your project. So you often use when you have a development environment, you open a project, and this is what you open. For Fortran, we need to actually enable that it handles Fortran. So we have to do enable language Fortran. And this is not on by default, which is for C and C++, you don't have to do anything, but for Fortran, you have to do this. And then you do, okay, add executable. I want to create an executable called simple, and it contains these source code files. That is everything you have to do. So now you have that is the description of the project, and if you deliver your source code repository, you have this cmake list.txt file in your source code root. There is no make files that will be generated from this file. So let's see here if we can go into. Simple. So what you do in your project is that you have a single file called a cmake list.txt. That is the same thing as you use make, that you have. If you have a file name like that, the cmake command line tool will look for this file when it wants to build something. And we look here in this one here. We have this very simple project here, testing, and then an executable here. So what you can do then is you can do just cmake here. CMake, we have to tell where it should look for. So CMake dot. Now you can see here, it will check here what kind of environment do we have. We have a C compiler here, we have a CXX compiler, and stuff like that. No, I didn't do a Fortran, I have to do that as well. But, what it did now is it created a lot of files in your source code directory, which is not something we really want. So the recommended way of using CMake, so let's do rm CMake cache. So see here, if you do that in the source code, if you want to clean up this, you have to do this manually like this, which is not optimal. So also that it creates a directory. So let's change this to a Fortran program as well. So we do vim main.f90. Insert program. So what we need to do, support Fortran, we needed to do enable language. I can place Fortran like this, and change to make F90 as well. So now we have a CMake list, and we can remove our C++ file. like this. So what we do with to be not to kind of spam our source code folder with build files, we can do make dir build. We go into the build. It's empty now. Then we do cmake ... So then we ask it to create the build files from the information that is in the parent directory. And now it does the same thing. Now it complains about you should put this one here, so we do that as well. So no, it shouldn't complain again. cmake ... Yes. So if you look what we have in this directory now, so by default, if you are in a Linux environment, it will generate a make file. So if you look at this file here, it's a large make file. But it has a lot of built-in things, and you can see it has clean, depend, edit cache, rebuild cache, simple, and a lot of things that you get for free here. But you can use it just like this. You just like make. Okay. I need to write the correct Fortran code as well. Simple like this.
Right, so there's no compiling.
So make. So now it built it. So that's one way of using it. But it can also generate other things. So if we go back here again. We do make dir build bs something. If we do cmake minus, I think it's here. So minus uppercase J, that is the generator command here. And if you can see here, you can all the things you can generate. So we can try to, for example, do build files for code blocks, for example. You can do you do cmake minus J, and then you give it the name here, for example, code blocks Unix make files ... like this. Now you can see here, it created a testing.cbp file here. That is a CodeBlocks project file. So now you can open that in CodeBlocks and use it directly in CodeBlocks. And I use it in, I don't have a Fortran compiler for Windows here, but you can see here. So now I'm opening a Windows command line prompt, and I have another project here. So here I have a cmake list file, and you can see here I have build debug, build release here. These are directories that are created here, and you can see there is no make file here. I have I have this file here, and this is a solution file for Visual Studio. So I can open this just by typing. Either I can open Explorer, I can do like this. So type it right here. So now it opens Visual Studio, which is a development environment for Windows, but it's generated from this cmake file. So I can generate. If I'm used to working in a development environment, I can generate that from the cmake file, and I can work happily here in my Visual Studio environment with all my code here. and I don't have to do anything special to use Visual Studio. I don't have to provide Visual Studio solution files. I just have to provide a single file for building. So if I go back here again, I can just show how this looks like. So here I have a bit more complex file here. I have a language C, C. I have also set which standard C++. And then I have some other dependency packages here. Include directory, add subdirectories, and so on. So it's very useful when you have a larger project with a lot of dependencies. It will this you can provide to any platform. So you can do this on Mac, you can do this on a Linux machine. With a single file, and you can also have if statements here, which I will come to shortly here. So continue here. As I said, you have a CMake list file, and then you do CMake dot, and this is what I recommended you to do. What you also can do here is that you can specify what kind of build you want to do. So usually when you compile, you can have an optimized build, or you can have a release build, and you can specify that here using CMake build type release. And usually, my way of doing it, I create one directory called build debug and one build release, and then I run CMake in each of those to create the build thing for both of these two types of builds. So with this here, you can define certain variables here to control the build. You can also, if you have dependencies on libraries for your executable, you add a second statement here, target link libraries, and then you give the name of your executable here and dependencies here. And the nice thing with this way of doing it is that for a Linux environment, it will use libblas.something. So you give the name of the library, not the actual file name. And on Windows, it will search for blas.lib. So you give it the high-level names here, and it tries to figure out the platform-dependent libraries here as well. Now, usually you always have to have some kind of logic here, because on Windows, the library is called BLAS32 or something, so it's not the same as on Linux. So, but it still tries to avoid having platform-dependent names in the dependency lists. But what you can do to handle, if you have dependency differences in your code, you can have if statements here, because this is a full language. So when you run your CMake file, it will execute your CMake file, and you can have if statements to do different things on different platforms. So you can see you have if Unix, if Linux, if Apple, if Win32 to control how it's built on different platforms. So in this case, this message will only be printed on a Unix platform. So then you can do stuff like this. So if Unix, then I have my executable here. I have these libraries, BLAS and M. If I'm not on a Unix platform, so then I have, okay, it's a Windows platform. Then I link with BLAS32, for example. And then if it's not any platform it knows about, you can print out, this is not a supported configuration. You can also define your own variables using set. So then you have set myvar, this is a variable. And then when you use the variable, you reference them with using $ curly brackets here. You can also create lists, and then you have my list here, and then you specify the things with spaces between them. I'm not too fond of the syntax, but this is what we have. So you can, for example, do my list A, B, and C, and then you do for each my list, and then you will print out A, B, and C. So here you can have, for example, if you want to build 3 different types of builds, you can have a list with different builds here, and then you loop over them, and so on. You can also control optimization in a more platform-neutral way, so you can do CMake Fortran flags release. Those are the build flags for a release build. CMake Fortran flags debug. Those are the flags for a debug build. It will choose some of the default options here as well. But if you have, for example, have different Fortran compilers you want to compile for, you need to kind of specify these. There are different flags here you need to specify. You can also choose the compiler using CMake Fortran compiler. So this is a complicated build here. You have GFortran here. So if the compiler is GFortran, use these compiler flags for release and these flags for debug. If you have an Intel compiler, you can add certain flags here, D77 and so on. So this way you can have control the compilation in more detail. As said before, it can generate projects for Visual Studio, Eclipse, NetBeans, Xcode, and more. And you use the G command here to select the generator here. So in this case, I can do for Eclipse, CDT4, Unix makefiles. And it will generate a project file here that you can open in Eclipse. So that was what I wanted to show today. And if you're using Qt Creator on Windows or on a Mac, with the plugins for this course, it will generate CMake files for you automatically. And Qt Creator can handle CMake files just like they were projects. So if we start here, for example, Qt Creator, and we do File, New Project, Non-Qt Project, Plain Fortran Application, choose my you can see here that it has CMake here. And when you create next here, let's see here, select. You only have to select one of these here. And here you can see you have debug, release. These are the profiles in CMake as well. So these are, you can see it build directories where it will generate the build files. You don't have to know so much about it, just press finish. And then you can see here, the spinning here is when the CMake is running and configuring the code. I think you can see it somewhere here. Yeah, here you can see it. It's running CMake. And now it didn't find a Fortran compiler, which but you can see here it generated a CMake file here. And here I have done some special hacks here to get it to work on different platforms. But you can see here that it have a project here, my Fortran code, and it looks for all the Fortran files in your current directory, and then it adds an executable with your Fortran code files here. And then you have a Fortran code here. So this is the, and you can see here that here is a build directory here as well inside this thing. But for some reason I didn't have a Fortran compiler. But yeah. But the thing is that you can. This is what it works with. And also, if you already have a CMake file, you can open that as a project here. So if you do open project, you can see here that it supports CMake list files. And that is considered a project. So if you have an existing project and you want to work with that in Qt Creator, you can just open a CMake list file and it will create a project on the fly for you. So Qt Creator is nice because it recognizes you don't have to create your own Fortran project inside Qt. You can just open a CMake list project file, and then it will create a project and you can work with that.